This is VisualSwift version 0.4 build 5. So in VisualSwift is a framework for using visual programming to create apps. I'm currently using it to generate audio, mainly virtual software synthesizers. You start by creating a project. This is an empty project. It just has a schematic. That's like your root schematic. On the bottom right, you can see these icons give you access to panels, to a side panel, and you have the X for quitting. So I'd say if we quit now, we have an untitled project. You can give it a title, and then you can go back inside it. So the first side panel is the components and libraries. I'll go through them. AV follows Apple's AV Foundation framework. The main components here are AV audio out. That's how we get audio to go out so we can listen to it. And the audio reverb. Then we have data types like bool, float, int, string. And we also have polybool and polyfloat. So polyfloat is like a float, except there's one per voice. At the moment, VisualSwift uses 4 voices. When that's working well, it will be incremented to user selected number of voices. And another important thing to know is float. The float data is not just a float, it's a float with a timestamp. So they're like timed events, and when a timed event happens, it's inserted in the audio stream with sample precision, which is quite important. So then we have views and modifiers, and these two follow Apple's Swift UI, therefore creating user interfaces, as you will see in a moment. The trigger is just a trigger. It has no payload data. It's just like action to trigger actions. So next side panel is the bundled. These are modules that are bundled with the app. This is similar to the custom. In this area, these are like your own modules, which you can drag from your schematics into that drop area, and then they stay there for use in other projects. Let's go back to the bundled ones. So let's drag a module in, like this is an oscillator, and let's drag audio out. So there's quite a few things to learn here. The little triangle is for going inside modules, because this is all hierarchical. So modules can have other, or components can have other components inside, which have other components inside. And this triangle is how you look inside the component. For example, this H stack inside has another schematic. It also has a properties panel. In this properties panel, we have the canvas scale, which we can change, which is quite useful. So we can fit more of these components in our schematics. When they're used in a synthesizer front panel, the canvas scale doesn't affect it. This is just for what we see in the schematic. So the canvas is this area in the middle of a component. Then we have the resize. We have a menu. We have a header we use for dragging it around, and duplicate. And from the menu we can delete it. And so then we have connectors to the left, which are inputs, and to the right they are outputs. So data in general flows from outputs to inputs. Like we could connect these two together. It goes from an output to an input. These yellow components are UI components, and the yellow connectors are UI connectors, therefore composing user interfaces. For example, this H stack stands for horizontal stack, so it aligns sub-elements horizontally. Like here we have a volume knob and a reverb knob. If we go inside it, we can see here the same. This is our volume knob, this is our reverb, and they're connected to the content component. This is the component that defines what's in the UI of the parent component. For example, if we unplug the reverb, you see it disappears above. If we plug it back, it appears. And then we have the V stack, which is similar to the H stack, except it aligns them vertically. You can see if we go inside it, we have like a title, reverb, then we have a knob, then we have the current value of the knob. For example, if we unplugged it there, we just have the title, or if we unplug it there, we don't see the value. Also, we have these brown components, they're modifiers. Here we have a padding, a background, and a corner. A corner radius. You can see the corners are round. If I unplug the corner radius, it's a subtle difference, but the corners are not round anymore. Or if I take out the padding, plug it directly to the background, you can see there's no padding anymore. So each of these colors and connector types has a different function. Yellow is for views, brown is for modifiers. Then we have the AV for AV Foundation Framework. The blue ones are mono. The light gray and white are poly audio streams. So these ones have 4 voices going through, which is indicated by the 4 dots you can see on the link. And they're added before they're converted to a mono stream. All the voices are added together. And in this case, we're keeping it separate, the left channel and the right channel, to create stereo effects. Then we have green is for data, and this is timed data, so they're like data events. When we move this knob, we can see the links and connectors. They go red because there's float events flowing through them. So the red is like a visual feedback to show that something is going through them. We also have ints and strings. They're all green, so because they all function in a similar way. The data events flowing. So let's try and connect this and create some sound. Our oscillator can go to the left channel, right channel. We need some MIDI input so we can play some notes. Now MIDI has frequency and gate, but this is float connector is different from the one we've seen before, because this is a poly float, so it's basically one float per voice. So we plug it to the oscillator. And now if we switch our audio on, we'll have 4 voices playing. We'll be able to play on the iPad's keyboard, but the notes will stay playing all the time. They won't release when we unpress the keys. loud. So now we need an envelope to have an attack and a decay. So we have a bundled envelope module that we can use. Let's plug it to the left and to the right channel. And now this envelope needs a gate to trigger the attack and release. Let's switch the audio on again. So let's have a slow attack. Okay, so far we don't have a filter. So that's next thing, filter. I want to have the canvas at 60%. So now we go from oscillator to the filter. The filter needs a frequency because the cutoff depends on the note being played. And it also needs the gate because it has an attack. It has an envelope inside. It needs to know when attack starts and release starts. So at the moment we need to go back and switch the audio on. That will probably change to be more automatic. So there's a click sometimes because this is only 4 voices. When a voice with higher frequency that's replacing an existing one, or it's retriggering it, it's causing these pops. So the way to deal with that will be to have more voices, or to have a different way of allocating, or not retriggering. Put the volume a bit louder. So I think the next step from this would be to maybe have 2 oscillators. Plug frequency. Now when you plug 2 connectors to the same input, they get added together. And here we can detune this one slightly, make the other one 0. We could make this one like an octave lower. Etc. Now we're keeping at this point the stereo and right channels are the same, but makes it much nicer if we'd keep them separate. We'd bring another envelope, another filter, and then have left and right not being the same. So creating like stereo effect, especially with the detune, would probably be the next thing. Now if we would want to create a front panel for this, there's a feature that's missing, which is like or that's half done, it's not fully finished, which would be to group them and then put them inside a V-stack or a H stack. Would make it a lot easier, but for now I'm going to create one from scratch just to give an idea. And so let's say create document. This is going to be our synthesizer. We go to our bundled component. No, let's start by having a vertical stack. We go inside it, and now in our vertical stack let's have 2 horizontal stacks. Now in our first one we will put actually maybe I'm complicating this a bit, so let's just have a V stack for now. Now we go to our bundled modules. Let's have our oscillator. Plug it. So that's our oscillator. Let's have the canvas small so we can see. Or even better, one thing we can do is we can have a device modifier, and that will show us how it will look on the iPad. Okay, so that's our oscillator inside the VStack. Now let's bring an envelope, plug it to our GUI, then bring, sorry, before the envelope we want to filter. Here on the canvas I want to resize it. They should actually be already with a smaller scale in the bundled module, but oh, I'm plugging the sound. I don't want to plug the sound for now, but it's fine. I'll leave the sound plugged. So GUI plugged, sound plugged. Now audio out. To left, right channel. Plug the GUI. And now let's see how this looks. So this would be our synthesizer. We bring MIDI in. MIDI doesn't need GUI at the moment. So plug our frequency to the oscillator, frequency to the filter, gate to the filter, gate to the envelope, and that's it. Let's have our sound on. And now this would be, make it full screen, this would be our synthesizer. So have a higher, something is wrong with the filter. Okay, so basically that's a synthesizer. We also need them presets. For that we go to our standards, bring our presets in, plug it maybe on top. Oops. Plug it to the top of our VStack. And now we have our presets. Okay, so that's not working very well. Needs some work. But so then we'd have our presets on top, and this would be our user interface for our synth. And I think that's it. I'll show maybe other ones that I've created. So let's close this one. For example, this is a Euclidean rhythm generator. It has a very simple synthesizer inside it. Doesn't have a filter. So there's quite a bit going on here, and I think I will leave this for another time, but or maybe a quick explanation. So this there's 4 voices playing. They have a number of events and steps, and a rotation. You bring a clock in and it generates gates that go to this synthesizer, and then the notes we play through the MIDI input, they define the frequencies of the 4 voices. We can change the wave there, etc. I think that's it for now. I hope to make other videos, maybe more detailed. But for now, that's the stage this is at. So anyone that wants to help test it would be great. Don't have to be very early adopters because it has bugs, and sometimes it crashes, and also any projects that you make, they might not work in the future. So you'd have to be prepared for that, even though they probably work with just a few changes. Like things that stop working tend to be small parts of it. And that's it. Thanks. Bye.